Hey everyone, Steel from the Endless Sphere Forums. Just thought I might share a quick video on my KMX. Just some revisions I've made. So first thing is this battery that I've just done. So it's the 20 amp hour A1T3 cells, 32S 1P. And what I've done, I'll try to show you guys best I can here. But I used 2 pieces of aluminum. I'm not too sure the thickness of it, but you can see those little balance tap screws on there. They're M3 screws, so roughly the thickness of that screw. I'm not sure, but anyways, I use like a clamping method, which I may show you guys in another video. But what it does is it uses 2 M5 screws. Basically, they're drilled through the aluminum bar and go through the cell tabs and basically clamp it down. So they're like little clamps that clamp the tabs together. A lot of work. The screws are all countersunk into the little clamps, and they're all holding the pack together to form 32S 1P. I've broken the pack up into 2 16S packs because of its size. So there's one 16S pack, and then beside it another 16S pack. You can see better if I lift the wires up. There's a lot of wires here. So there you go. With all the balanced leads. That's what they're sitting at right now. They still need to be balanced a little bit better. I'm only on their first cycle, but they're roughly in pretty balanced up right now. From the pack, I'm using, for example, to connect the 2 packs in series, I'm using a dual 10 gauge wire. So basically, I dual them up, as you can see here. Two ring terminals in that end, 2 ring terminals down there, and yeah, you can see that. And basically, try to minimize the voltage sag as much as possible. Over here, I used again dual 10 gauge wire, and they go all the way to basically power pole 75s. It's right there. I'm only using 2 right now. This is kind of a test controller. So basically, just kind of a little feedback regarding how the pack is performing. So right now, you can see my nominal voltage is at about 106.5. Okay. I'm pretty sure that's really accurate. I just calibrated my cycle analyst right now with my Fluke multimeter, and temperature outside right now is probably about 12 degrees. Now, I did have the bike sitting in the garage, so it's a little warm in here, but 12 degrees. When I pulled the bike out, it was about, the hub motor was sitting at 20 degrees, so ambient temperature. This controller here that I built is able to sustain, again, from what I've tested with my amp clamp, about 150, 160 amps during acceleration, which is more than enough. And I'm just trying to determine if my voltage sag is noticeable, or sorry, is okay for how I built the pack. So basically, I'm sitting at 106.5 volt right now, and I'll see the pack go down to about probably just under 95 volts. So between 94 and 95, I've seen hitting under 150 amps. So just want to know if that is normal, or am I losing a lot of voltage sag, maybe through my connections if possible. Again, it is a 1P setup. These are short tab cells, so you have to understand I don't have a full tab, and some of these tabs are perforated, so meaning that there's little tiny holes in the tabs. Basically, what happens probably when these were meant to go in like an A123 systems pack, and maybe they didn't tab weld properly, and that's how I got them. I haven't tested all of them for capacity and all that. I'm going to run in the bike, see how they go. Everything looks good so far, and I've tested a couple of cells, but nothing in this pack. It's just put together. So yeah, so they're short tab cells. I don't have a full tab to mount to. And also, you have to keep in mind that when I did these connections, you can't see it here, but where the two M5 screws go through. So for example, we'll look at this to show you an example roughly where the holes are on the clamp. I have to actually cut a little bit of the tab out to allow the clamp to slide in to clamp the tabs together. So I did lose a little bit of material off the cells, but I like the way I did it because this will allow me, if I ever have to service the pack for a reason, if let's say I just burn out a cell, I can cut off the tape, and might take a little bit of work to get to it, but the cell is easily removable and replaceable. So that was the idea I had in mind when I designed this pack, is to be able to service it if something went wrong. Other than that, I was recommended by Dr. Best to use my fluke meter between a 2-piece string of A123 cells, which I did. I'll just show you where I connected it, if you can see. So keep in mind I don't really have much space to clamp everything, but I clamp one there, so a little black terminal, and I put one to this one right here, which is the most positive on the pack. So it's connecting, the wire actually runs down and it goes into the ring terminal down here. So it's the closest connection I could get, and what I'm seeing is under full load of the controller, so as I said, under about 150, 160 amps, I'm seeing the cells, a 2S on the pack, go down to about 5.9, so roughly 2.95 volts a cell under 150 amps load, and that is measured directly from the cell. Just the random 2 cells that I decided to pick in the pack, and that's on the most positive, so that's probably where we're seeing the most load. So yeah, let me know your thoughts, guys. Doc, I know he's gonna probably end up watching this, and let me know what you think, because Doc mentioned that it seems a little bit excessive to get a 10-volt drop, but I think it's normal for the conditions, I guess, and the temperature. I'm not sure, but that's that. Just want to show you also my little controller here that I built. So this is I'm not sure if I did a video on this, but it's a really cool controller I did. Now the wire coming out of it is not too fancy. This was only originally supposed to be meant to be a low current controller, but I've kind of tweaked it up because I just wanted more power. So they're all 12 gauge Turnigy wires for even the power too. You can see one of the power leads right in the middle there. So it's all 12 gauge single wire. This is using the IRFB 4568 MOSFETs. I'm going to do the best shot I can here. But if you look at the way the legs are, see that one MOSFET right in the end? It's very interesting the way I bent the MOSFETs to get them all to fit. Because as people who have seen these boards, these take TO220 MOSFETs, and I've retrofitted TO247 MOSFETs. The low side uses one copper bar that the MOSFETs face down on. That goes to the case. The high side at the top uses dual copper bar. The surface contact side of the MOSFET, I should say, actually faces this way, to this side, not to this side. Like down here, obviously the surface side faces to the case and the bar, but on this side they're facing the opposite way because of the way I had to orient the MOSFETs. And I used the copper bar with this heat spreader from it's a VGA cooler heat pipe. That's what I'm looking for. And yeah, so it's got the copper bar plus the heat pipe. So the heat does come here, and this gets really hot actually. And not only that, I also have a 100 degrees temperature set off, which I've never hit yet. But if it ever hits 100 degrees, the controller will shut down to prevent damage to it. So yeah, that's the controller I'm using. For this setup, that controller is being pushed really hard. It is, as I mentioned, pumping 150 amps, 160 amps through 10 gauge wire. So to give you an idea, again under full load of the bike right now, if I measured the terminals of the pack, So the positive and the negative terminal, I get a drop of about 94, 95 volts. If I look at my cycle analyst, I'm getting another 5 volt drop, so I'm going from like 105 down to 90. But keep in mind, I am putting some pretty serious current through these little 12 gauge wires. I had never intended when I built this controller to push it as hard as I am, but it actually is run really reliably. So I might actually open it up and double up all the wires to dual 12 gauge and get some more juice out of that little guy. So it's running exceptionally well. I'm in the market for a new motor. The X5 has served me well, but with higher current, higher voltage, as everybody knows, the X5 just seems to dissipate it all in heat. So I'm in the market right now for a motor. I'm not sure what I'm going to be going with yet. So the options are the 54 series, which has some great reviews from Dr. Bass saying that it runs much cooler than an X5. So that's my primary option. Secondary option will probably be maybe a Grayborg motor from Methods one day, but I'm not sure on that. And then the last option, if I save all my pennies and my dollars, is to put like an Enertech motor on there, which is like a $1,200 motor, which will probably get me through any kind of power I could run to the back. So haven't decided yet. A lot of options. Just depends how much money I want to spend, really. But hope you enjoyed my video on the bike. I don't know what else to show you guys. That's pretty much everything. Oh yeah, and for the hell of it, I am using fuses. They're 430 amp fuses, so that all protects everything. God forbid something hits the fan. Who knows? And also, I got my little temperature probe. So right now, the motor's been sitting for about 12 minutes. Well, I've done this video for about 12 minutes. I just brought the bike and I went for a ride. Let's say this bike's been sitting for about 20. Still at 81 degrees, so this motor is like still hot. Retains the seat for quite a while until it cools down. But yeah, so hope you enjoyed my video. Love to hear your comments. And alright, till the next video, have a good one. Thanks.